Hello. Today we're going to interpret summary representations of data through pictures and tables. There's going to be 4 slides that I go through in this video. First, we're going to do frequency tables. So what you see in front of you is a set of data. A math teacher gives a test and sees the following scores. You see there's a range of data, goes from the 40s to the 90s. There's a couple things we might want to know about this, but it's basically right now just a long list of numbers. I've already organized it low to high for you. However, in the real world, a lot of times even that hasn't been done yet. So frequency tables are the first way that we can start to make sense of the data we see. So what we're going to do is this. We're going to make a table that has 2 columns. We're going to write scores in one column and frequency, which means how many, in the second column. So, and then we can make a choice. How would we like to divide these up? We could count by ones, 42, 43, 44, 45. You notice that's going to be kind of boring because there's a lot of gaps in here. We could count by fives, so like 41 to 45, and then 46 to 49, and so on. It's kind of up to us. I'm going to recommend, in this case, that we count by tens. Let's say 40 to 49. And then the next one would go 50 to 59. And then 60 to 69. Again, this was just a choice we made. We could have counted by anything. 70 to 79. 80 to 89. And then 90 to 99. We don't have to go higher because we can see that there's no, that's it. And then frequency is just how many. So if we look up here, how many data points have are between 40 and 49? Well, that's just 1. How many data points are between 50 and 59? Well, there's none. We're not going to leave that blank, so we will say the frequency is 0. In the 60s, there's 2. In the 70s, there's 1, 2, 3, 4, 5. In the 80s, there's a lot more. 1, 2, 3, 4, 5, 6, 7, 8. And then finally in the 90s, 1, 2, 3, 4. Should be able to count this up. There should be a total of 20. And what you notice here is this. This frequency table represents this. And if you look at something like this row, what this says is 2 students scored between 60 and 69. Like the row above says 0 students scored between 50 and 59, and so on. So interpreting these rows, they come from that. All right, our next representation is going to be dot plots. Now a dot plot is basically just an x-axis. So I'm going to draw a horizontal line, and every data point is represented by a dot, like it sounds. So I'm going to count by tens, but I'll put little dashes for the fives. So 40 to 50, and so on. Again, put a little dash for each 5, and that makes it a little easier to see where your dots are going to go. And this is going to be nice because it's going to make you don't have to count. You just kind of put them where they go. So let's see. We got a dot at 42. 1 at 65, way up here, 68, 71, 73. We've got 2 at 75. This is the first time where we have 2. And just a general thing about dot plots is you try to make each dot the same size. So you can, like 2 dots should look twice as big as 1 dot. And another 76, 80, 81, 1, 2, 3 at 83, 87, 88, 89, 90, 93, 95, 97. A dot plot does a little bit more than a frequency table does. You notice there's a lot more detail here. You can see exactly where each point is. And just a reminder what this means, this dot right here represents 1 student. So a single student scored a 65. So in this dot plot, each dot represents a person, and their score. One also nice thing about dot plots, and this is going to be true about our next two as well, is that it's really easy to see what an outlier is. So an outlier is a data point that's far from the rest of the data. You can just visually see it. Makes it really easy to see. Next one, histograms. Histograms are basically dot plots when we get tired of making dots. So I'm going to do a histogram based on tens here. So we're going to do it the same way. And we're going to say 40 to 49, and then 50 to 59, 60 to 69, and so on. This is going to take a moment. So after you've finished, you notice that these are the exact same as the frequency table, and I did that on purpose. The frequency table basically is a histogram. A histogram is a frequency table in picture form. So the y-axis of this is going to be frequency. And I'm going to go back to my frequency table, and I noticed that from 40 to 49, there was only one. In fact, in any particular group, the highest I went to was 8. So on my frequency, I'm going to make 1, 2, 3, 4, 5, 6, 7, 8. That's the highest it goes. And then I'm going to use the numbers from this. So 40 to 49, there was 1. So I'm going to make a bar up till 1. This is instead of making one dot, I just made a bar that goes to 1. Going back to the frequency table, then there was 0, 2, 5, 8, 4. So in our histogram, 0 means there's nothing. 2 means this goes as high as the number 2 over here. The next one was 5, so the next bar would go up to 5. So 2, 3, 4, 5. I'm going to try to make my best drawing here. Sorry, that's not perfect. The next bar should go up to 8. And then the last bar we said it was going to go up to 4, so that should be this one, a little bit less than 5. You notice just like a dot plot, you can still see some stuff, like the outlier is really easy to see. It's got the same information as a frequency table. What's nice about a histogram is, compared to a dot plot, is you don't have to count every dot. How do I know that this goes up to 8? Well, I look across and there it is at 8. A reminder of what this means. Same thing that I circled in the frequency table. This bar goes to 2, which means this bar represents 2 students scored 60 to 69. This bar means 8 students scored 80 to 89, and so on. So basically, histogram is a frequency table in picture form instead of just the numbers. Our last representation in this video is a stem plot. Stem plots are a unique type of graph. Typically, they represent, well, the way I think about them is a sideways dot plot. So you know how in a dot plot or a histogram, your x-axis goes side to side. In a stem plot, it often goes up and down. And the typical way to do a stem plot is you put your 10 spot inside the stem, and then the 1 spot in a number is the leaves. So I'm going to put a dark line there. This is going to be vertically oriented. And I'm going to put a 4 to represent the 40s, and then 5, 6, 7, 8, 9. You could even put a 10 to represent the hundreds. So 40s, 50s, 60s, 70s, 80s, 90s, 100. And then we put the 1 space, that's the leaf that goes off. So that 2 right there, I'm going to put a single 2 on the outside. So that 2 doesn't represent the number 2, it represents 42. There was nothing in the 50s, so I'll leave that blank, but then there were 2 60s, and we typically go low to high, inside to outside. So there was a 65 and a 68. So I'm going to put a 5, and then I'm going to put an 8, kind of like equal distance out. So this means a 65 and a 68. There were 1, 2, 3, 4, 5 70s, 71, 3, 5, 5, 6. So 71, 73, 75, 75, 76. Everything in this row is in the 70s, so I'm only writing the 1 spot. We know there's a bunch of 80s. 80, 81, 83, 83, 83, 87, 88, 89. So I'm going to put all those 1 spots going out, starting with 80, 81, 83, 83, 83, 87, 88, and 89. And then there's 4 in the 90s. So 90, 93, 95, 97. So 0, 3, 5, 7. I can't rotate my screen right now, but if you turn your head sideways, this should kind of look like a dot plot. In fact, it should basically look the exact same as this histogram as well. The only difference is it's got more information. Instead of a histogram that just went to 2 bars, this shows you not only that it goes to 2, that there were 2 people in the 60s, but exactly what they got. It's kind of like a sideways dot plot where the dots are actual numbers. The last thing that you always need to put for stem plots, or you always should at least, is a key, because this is not the most common thing in the world, so it's always important to write what this means. So 4 bar 2 means 42. There should always be a key. If there's not, then someone made a mistake. Just as a reminder, when you see this, like this 5 right here, that's not actually a 5, that's a 95. So this means there is a student who scored 95. And that is it. For a recap, we've got frequency tables, dot plots, histograms, and stem plots, all ways of showing a picture of this data.